All right, so what we're going to go over is what we learned in class, which was how to multiply and divide rational expressions. All right, we started out by talking about how to simplify, but now what we're going to do is bring in some operations. So I just want to review real quick about how we operate in general with fractions. Okay, let's suppose that we have the problem, we're taking 4/15 and we are dividing this by 18 fifths. Okay, well, the first thing that I want to review is that when we divide fractions in math, what we actually do, okay, is we multiply by the reciprocal. And so all of our division problems are going to basically turn into multiplication problems, and we're going to flip this fraction and make it 5/18. Okay, so just in words, what we're doing when you divide, what we do is we multiply by the reciprocal, okay? And the reciprocal means that you flip the numerator and the denominator. And so really, like I said, we're always going to be basically multiplying. Well, before I go across, okay, so what's nice about multiplying fractions is you don't need a common denominator. You basically go across the numerator and you multiply, and then you go across the denominator, okay? But I don't know that I necessarily want to take 15 times 18 and then have to reduce it. So what we can do is we can do a little bit of cross simplifying. And what I notice is that 5 and 15 have a common factor of 5. So 5 divided by 5 will make 1, and 15 divided by 5 will make 3. And so we're reducing those numbers. And then what I notice is that 4 and 18 have a common factor of 2. So 4 divided by 2 is 2, and 18 divided by 2 is 9. And so we can cross simplify, right, because of that division. And then when we go across the numerator, we've got 2 times 1, which is 2, and 3 times 9 is 27. And so if we do our simplifying first, then when we go to multiply the fractions, it will already be reduced. So that's the idea that we're going to apply to these algebra problems. All right, so let's start with example 1. Let's suppose that it is x minus 3 divided by 2x minus 10. Sorry about that. My pen right here. 2x minus 10. And we're going to divide by x squared minus 9 divided by x cubed minus 125. All right, so the other thing too that we're going to do is we're going to review our different types of factoring in this problem. All right, well, let's first rewrite. Okay, and when we rewrite this, okay, we multiply by the reciprocal. So this is x minus 3 divided by 2x minus 10. And we're going to multiply by the reciprocal, and so let's flip this fraction right here, okay? Divided by x squared minus 9. So now what we're going to do to simplify, before we multiply these fractions together, we want to do a little bit of cross simplifying, and we do that by factoring. So x minus 3 is already factored. Let's go ahead and read that. Now this 2x minus 10, we can take out a greatest common factor. So if I factor out a 2, the result will be x minus 5. Now, this numerator right here, we need to remember the type of factoring for cubes. And what we do here is we factor this x cubed minus 125 into a binomial and a trinomial, okay? We kind of nicknamed this factoring the SOAP factoring, right? Where the signs go same sign, opposite, always positive. We can look back in our notes if we need to, but I'll do what I can right now to walk you through it. So this first binomial is the 2 roots. So the cube root of x cubed is x, the cube root of 125 is 5, and we put the same sign in between. Now in the trinomial, we take our first root x and we square it. In the middle of the trinomial, we take the 2 roots, 5 and x, and we multiply them. And for the last term of the trinomial, we take the 5 and we square it. Okay, so there's a formula. Like I said, we can look that back up. And then finally, the SOAP part is the first sign is the same. The second sign is O for the opposite. And the last sign is always positive. That's where the A and the P come from. Okay, so that's how we factor that cube right there. Now, x squared minus 9, this is what's called the difference of squares. And these always factor to be the same way. When it's a minus sign, we can split the terms 50-50. So it's going to be x, and we split the 9, and the signs always go plus minus. So that should start being one of the easier types of factoring. Now, before we multiply the fractions together, we want to simplify everything that we can. So is there any factor that you see in the numerator and the denominator that we could divide? Well, the first thing I see is this x plus 5. So I'm sorry, I said that wrong. X minus 5 divided by x minus 5 equals 1, so we can simplify those. The other factor I see is x minus 3. Well, x minus 3 divided by x minus 3 is 1, so we can simplify those. So now when I go across the numerator, I have x squared plus 5x plus 25 in the numerator, and in the denominator is 2 and x plus 3. And that is our simplified product of, or quotient, really. I guess that what we were doing was dividing, but that is the simplified answer, okay? And you know what? It's okay, too, if you want to take the 2 in the denominator and you want to distribute it and write it as 2x plus 6, this is okay as an answer, too, okay? So that's kind of the way that this is going to work. Let's try another example here. Let's suppose that we have x squared minus 49 divided by x cubed y squared times x cubed y divided by 2x minus 14. All right, so now we've got a multiplication problem. So first what we need to do is we don't need to worry about that multiplying by the reciprocal, but first what we're going to do is we're going to factor. Because if we can simplify any of the factors, that's what we want to do before we multiply. So what I see here is in the numerator, I have the difference of two squares again. And so I'm going to factor x squared minus 49 into x plus 7, x minus 7. Now we can factor this denominator because x cubed just means that we have x times x times x. Those are the factors. Y squared means y times y. So that's what that monomial right there looks like factored. Now again, I have this monomial term, and I can factor that into x times x times x times y. The denominator, we can factor out at 2, and we have 2 times x minus 7. So now that everything has been factored, we can simplify those factors. So what do we see in the numerator and the denominator that divide? Well, the first thing I see is x minus 7 divided by x minus 7. The other thing I see is we've got these monomial terms right here. If there's 3 x's, this x times x can simplify with this x times x times x, and those cancel out. And the last thing I see is a y divided by y. So this, we can take, sorry about that. So these simplified, and then finally, 1y up here divides with 1y in the denominator. So everything now has been simplified. So now let's multiply this, and the numerator is going to have an x plus 7, and the denominator, I see that the two factors are 2y. So this is the product of the two fractions simplified. Okay, so let's just do one more example because I need to show you an example of something that's called a complex fraction. All right, so a complex fraction is going to look like this. Let's suppose that we have 2x minus 1. Let's suppose that it is 2x minus 1 divided by 2x plus 6 divided by 4x squared minus 1 divided by x plus 3. Okay? And it lives up to its name. I mean, it is a complicated looking problem. Most students, when I put this on the board, kind of look at me funny and just assume that the problem's going to be difficult. Well, it's not, because we need to understand the structure of it. This is the top fraction, and we're dividing it by this bottom fraction. So I want you to start by rewriting the problem as a division. So what this means is the numerator fraction is 2x minus 1 divided by x plus 6. And we're dividing that by the denominator fraction, x squared minus 1 divided by x plus 3. So this problem in black means the exact same thing as this problem right here in blue. So it's just a matter of understanding the structure and rewriting it. Now what we're going to do is we're going to multiply by the reciprocal, because that's what we do when we divide fractions. So 2x minus 1 divided by 2x plus 6, and we're going to multiply and flip this fraction, 4x squared minus 1. All right, now before we multiply, let's factor and simplify anything we can, and then we will multiply the fractions. Well, 2x minus 1 is already factored. 2x plus 6, we can factor out a 2. X plus 3 is already factored. And 4x squared minus 1, again, this is the difference of two squares. And so we can factor that into 2x and 2x, and we can split the 1 into 1 and 1, and it always goes plus minus. Okay? So now comes the simplifying part. What do we see that divides? Well, I see that 2x minus 1 divided by 2x minus 1 equals 1, so that cancels. And x plus 3 divided by x plus 3 equals 1. So now when we find the product and we multiply, we go across the numerator, and since all of those factors divided, we have a 1 in the numerator. The denominator is going to be 2 times the factor 2x plus 1. So I'm okay with you writing it like this, or if you would prefer to distribute and make it 4x plus 2, these two answers are the same. Okay, so that's how this works. We only took notes in class. We did not learn anything new. And so get all of that down in your notebook, and we'll practice more next time you're in class. Thank you. Bye.